Hello, everyone. I'm excited to talk to you about Sleep Angel, which is the sleep improvement system that I developed during my PhD. And for those of you who are into buzzwords in AI at the moment, it is Multi-Agentic, which we can get into. But before we start, I thought I would share with you a little bit about why I did this. So the most important thing here is that sleep really matters for our health and our wellness. I'm not sure whether many of you are into sleep, but for instance, not getting enough sleep when you get older is associated with an awful lot of diseases. And it's also associated with workplace accidents. For instance, you're 1.8 times more likely to have an accident if you haven't slept well the night before. And also your cognitive ability goes down if you haven't had enough sleep. So it's a really big deal. And each of our behaviors in our environment drive how long and how well we sleep. But everyone's sensitivity is different. So I'm going to share with you a bit of that, like when your parents are on your case telling you to turn off your screen at night, I've got some useful information for you to use with them. And my sleep improvement system figures out for each person what behaviors and environment matters. They get a personalized recommendation and it helps them change their behaviors in the environment. And the best thing is, from my perspective, is it actually works. It improves people's sleep and their slow wave sleep. And I've got some cool stuff on trust. I understand that you guys are not just into the technical side of AI, but also the ethical side, which I'm very passionate about. And if you are yourselves going to be building decision or behavior support systems, I've got some cool tools that you could use too to make sure you're building trust with your users. So with that, here's a bit more on my motivation for doing this. As you can see on the left-hand side, this is someone who's not sleeping well. If you sleep less than 7 hours a night, there will be, over time, particularly when you get older, a health and wellness impact. And if you're not a chronic insomniac, and chronic insomnia is a mental health challenge, the main treatment that you're going to be offered by the doctor is something called sleep hygiene. And that may be something that you've heard from your parents, like, get up and go to bed at the same time every day. Don't drink coffee too late. Avoid light in the evening. Now, the problem is that although they do actually have some impact in trials, all the trials so far have been subjective. So it's basically someone says that they sleep better, but actually in real life, only about 47% of the time is there a correlation between what someone says about their sleep, when you objectively measure it, what was going on. And there's also limited personalization, although everyone's very different in terms of their sensitivity. And then the other really cool thing about sleep is there's a particular type of sleep called deep sleep, which you get in the first half of your night. And that is amazing. It clears your brain of plaques, which are negative for your for basically things like Alzheimer's disease. It's all things that matter when you're later. But interestingly enough, there's been really no research whatsoever as to whether sleep hygiene can improve slow wave sleep. So lots of opportunity to use objective data. Now, if I was to give you a quiz on what all the things are to do to sleep better, you guys would probably get, I'm sure, at least 50%. That's what most people get whenever I go through this with them. But at a very basic level, these are all the things you could do to sleep better. So during the day, you should be getting exercise, you shouldn't nap, you shouldn't drink caffeine, you should eat early, you should get loads of natural light. You should relax in the evening. So about 2 hours before you go to bed, you should be avoiding evening light, relaxing, not having a lot of liquids before you sleep, and not, smoking or taking other drugs. When you go to sleep, you should be retiring to what I would call a sleep sanctuary. It should be cool, dark, and quiet. And you shouldn't be having things like electronic devices or computers in your room, because that can remind you of things when you should be sleeping. And you should be in bed long enough to sleep and a consistent arise time and bedtime. Now, no one person can do 16 things, And the really cool thing is individual sensitivity differs. I said I was going to share with you something that you might find useful with your parents, because the average person, when you give them like candles and you check whether their sleep is delayed or not, well, the minimum, the most sensitive person relaxed to 10 candles worth, which is what's on the left-hand side. And the most, the least sensitive reacts to 480 candles worth. And I can guarantee you, if you're in the UK today and you stood outside at midday, you wouldn't get that much. So if you're like someone on the right-hand side, there's no need whatsoever to be avoiding evening light, versus on the left-hand side, you absolutely should. And there's no way right now that you guys can know, this is what your parents will say, is you don't know if you're on the left-hand side or the right-hand side. And if you're having trouble sleeping at night, it could well be that it would be a good idea to avoid light, and you've no idea of knowing. So that's what my sleep improvement system did. It measures your sleep and what drives it. So for instance, if a lot of light in the evening leads to less sleep, and it tailors personalized recommendations to help you sleep more and or deeper. And that's the explanation I gave my mother as to what I was doing. I always think that when you come up with technical solutions, it's a good idea to make sure that your mom would be into it. I'm going to give you now the more technical version, because I understand that you are some aspiring technologists out there. This is the technical version. So our system measures sleep and 16 sleep hygiene, behavioral, environmental factors. We did that over 2 months. We used smart devices and user digital inputs for things that we couldn't measure with a smart device, like the last time someone had a coffee and how much. We got AI agents to use this to create a personalized recommendation. And the user receives this through a digital interface along with their baseline report. That's basically what happened over the 2 months. And then over 1 month intervention, their daily tracker, which helps them implement the interventions they choose. So of that list of 16, they choose a maximum 3. So getting a bit more technical, we did our data collection through smart devices. Our users validated it. They checked it and they said, yep, I think that's right. I was outside in the middle of the day. So that spike, for instance, in my natural light is correct. So they built trust with the data, and we only put the data they trusted into the AI agents. And I used a combination of machine learning. So for those of you who are into this stuff, I did both regressions and classifications. And I tested about 42 regressions, in fact, to come up with the best one for each person, as well as a rules-based agent, which took what the expectations for doctors are and applied them. So an example there is something like caffeine. You're not supposed to have over 230 milligrams of caffeine per day, the average person. So if someone was having more than that, it flagged it as an issue. We put those two things together, the ML recommendations and the rules-based recommendations, into a recommendation for the user. And they got to choose 3 things from that and put them into action, which we tracked with smart devices. So the headline is these are some of the devices we used. The first one is Dream, this funky device this guy's wearing on his head, measures total sleep time and slow wave sleep. It's super sophisticated. It's an EEG device, for those of you who are interested, and it measures your brain waves and it classifies it into what type of sleep, so like deep sleep or light or wake. The Aura Ring, for those of you who are into these things, I've got one here. It's great for naps, for cardio and relaxation. You guys should never use it to measure sleep because it does it incredibly poorly. Like for instance, for an adult, it's only correct 40% of the time when the person's awake. So it's very poor on sleep overall, but it does pick up naps. This is me modeling on my glasses, LIS, which is how you would be able to tell how much light you got in the evening if you had that. So you could tell on your individual sensitivity whether you were 10 candles or 480. And this is Sleep Angel, which is a device I built myself. You'll see there that there's a little Arduino device with some 3D printed wings to make it a little bit more endearing to sit on your bedside table. And it measures whether it's dark, cool, and quiet. And it only measures it when you're asleep. So whatever else you're doing in your bedroom, it's not picking up any of that stuff. And it keeps it totally private. So it calculates everything on the device itself. And although it's got like a microphone to measure decibels, it only sends the actual decibel numbers to me. It doesn't send me what you said. So very private. Those are our devices. And then this is just an example for the regression. Luckily I got my number right. It was 42 algorithms we trialed for each participant. And those of you who have done regressions before, you'll know that you specify a target variable. Mine was total sleep time or slow wave sleep. And then I got the dream headband to give me that. And then those 16 practices I talked about earlier, I took those, I measured them with the devices I've shown you. So the Dream, the Aura, the Liss, and Sleep Angel. And then for those ones down at the bottom, that was the one I was saying, I did the daily digital survey. So the caffeine was an example. And those were my feature inputs. And those all fed in. And I used supervised machine learning and neural networks to assess what people were most sensitive to. And then this is, for my supervisors, they get very excited by this kind of thing. This is on the left-hand side is showing the mean difference in terms of minutes it had. So for instance, the average person over the whole of the intervention slept an extra 24 minutes, which is very material. And the red dotted line beneath it, which is about 15 minutes, is what the doctors need when they do trials. That's a significant improvement in sleep. So I had almost double that. And then on the right-hand side, I tend to like to look at slow wave sleep and REM as percentages increases, because obviously they're smaller than the total sleep time. You can see there that, for instance, slow wave sleep increased by up to 31%. So super big improvements in terms of sleep. So super exciting. And for me, the motivation is I'm very excited to help people get better health and wellness outcomes and also avoid Alzheimer's, which is what retarding slow wave sleep should do. And it does require more research. But the good news is we've got something here now that actually works and can be tested. I thought you might want to see some of the stuff that I did. People got personalized little packs. You can see there that Louise is in the left and Joss is in the middle. And you've seen that angel before, but it's dressed as an angel and it's meant to be endearing on the bedside table, but also I made the sensors visible so it was transparent what it was, and I explained it to people. And some of the things that you want to do if you want to build trust in AI is one is physical embodiment. So that's an example of the angel. That's, you can see what it is where the AI sits. And then the immediacy behaviors is personalization. So these boxes are personalized, but also the reports people got were personalized with exactly their data that they tested. So they really built trust in the data that they were using. We've got 3 new metrics to measure trust. And this is what I was saying would be interesting for you guys if you wanted to build a recommender system like this. And I'll bring alive some of what we did to do it. They are called Dirty, Dafty, and Dotty. And you can see that I got some generative AI help in generating these, but I think it did rather well. So the first one is Dirty. And in that one, when you're wanting to understand trust, the first thing is, in terms of demonstrated trust, did they say they would do something? So for instance, on the right-hand side, they were given this matrix and they were choosing up to 3 things on this. And anything in the top right was ranked really highly based both on the rules-based system and the machine learning system. But some of them tended to rely more on what the rules-based approach was, what a sleep expert would choose. So choosing things over here in the top left. And others would depend a lot more on what the machine learning was doing. So that was basically what we used to measure whether people were relying more on the machine learning or more on the rules-based approach. The next thing we looked at was demonstrated trust, but here in terms of follow through. So did I take action and do it? So not just did I do it, did I say I was going to do it, like, yes, mom, I'm going to do my homework, but actually I did my homework. And what I felt so exciting, like on the right-hand side, this is for all of the interventions that people chose. So for instance, let's choose one. Let's choose caffeine. So participant D chose caffeine. And when you compare for the month that they did the intervention, how well they did relative to baseline. If it's blue, they did well. If it's red, they did bad. You can see that this person literally cut their caffeine consumption by about 70%. So huge impacts, actually. Like they really did what they said they were going to do, except for a few here on the left-hand side. And what we do then is we look at, do people follow through on things that machine learning recommends relative to do they follow through on things that the rules-based system recommends, just to get a bit of sense about like how much trust they're demonstrating in their recommendations. And last but not least is, was I right to trust? So did the model tell me something that made a difference? Now, you guys saw the total sleep time statistics I had before for the population, but I thought you might be interested here just to see for a person. This person on the left-hand side, they've got their baseline and each dot is a night. You can see they average just less than 6 hours a night, which is, really not good. That person will be having trouble remembering things during the day. They could absolutely be having accidents. It's really important that they get up above 7 hours. And then the other dots all along the way, those are the distributions. So sometimes they got 9 hours when they got enough time in bed, but average of 6. And then on the right-hand side, you can see during the intervention just how much more tight the sleep was. And they managed to move it up to about 6.5 hours on average. So that is really quite a big change over a month. And the idea would be that that person would continue to do those activities and hopefully over the next month or two get over 7. So there you are. That is a whistle-stop tour, and I would love to take any questions. I hope that wasn't too fast and it made sense.
What kind of impact that Sleep Angel could have in cases like Alzheimer's?
Get this, it's completely mad. When you're in deep sleep, your brain passageways open up 60%, and then fluid, cerebral spinal fluid, washes in, flushes around, and then washes away these beta amyloid plaques. And these beta amyloid plaques, whenever you cut open someone's brain who's got Alzheimer's, that's what's clogged them up. So the idea is that if you can get someone's slow wave sleep up to an appropriate level, and for people who are between 40 and 55, that's between 1 hour and 1.5 hours. So if you get their passageways open for that period, then they can, by natural means, by their using their own biorhythms, retard, maybe even forever, Alzheimer's, because they'll be washing away the beta amyloid plaques themselves. We now know how to increase slow wave sleep, because as you saw there, by individually selecting for each person what will drive their slow wave sleep, they can implement it and we can increase it. And now we need to have research into the impact on beta amyloid plaques, but that will require an invasive test, and that's the next step.
Thank you so much for your answer. What was the inspiration behind Sleep Angel is one of the questions to follow up.
The inspiration was actually my mother. My mother doesn't sleep well. Every time I call her, she's like, oh, I slept so badly. And I got really annoyed that why wasn't she not doing something about it? Why not fix it? So I took her to like a spa type place where it was like a medical thing and they like taught her what to do. And interestingly, I was just like, she's never going to do it. Like, it's like these 16 crazy things. And I love the mental and the physical and the fact that each person is individual. And I thought I did loads of reading and academic research to understand whether I could like help my mom, tell her what it is she's supposed to do. It was absolutely impossible because there's just too many things and I didn't know which one would actually help her. So that was what inspired me to build it. And I'm sure you're going to ask me, is she sleeping better now? Yes, she is, but she still complains about other things.
Thank you so much, Tori. It's so relatable for you to come up with this idea based on your mom's experiences. But not least, I would like to thank Sage Foundation and Red Hat for their support as our sponsors for this event.